In the Notch Essential course, we looked at particles as a powerful standalone tool. In this chapter, we will be expanding on that by learning about particle physics. We will also start to look at connecting particle systems to other tools available in Notch, like deformers and cloners. The combination of different systems enables you to do such things as use particle systems to drive your clones, or use particle physics to drive mesh deformations, explosions, and more. This chapter is also a workshop, so follow along and feel free to pause or rewind at any point. Welcome back to Notch Intermediate course. In this chapter, we will talk about particles. So the first scene that we're going to be building is going to use particles with clones. So this is our finished setup. This is our end goal. So I think we are more than ready to start. I'm going to open the first layer called Clone to Particle Start. And I'm going to introduce you to the nodes that we have here available in the scene. So here in the bottom, we have a floor that's shaped 3D with a grid generator. We have a camera that we're looking through. And here on the side, we have several lighting nodes. We have skylight and we have fog scattering for the background. Now, the very start of this workshop will be rather fast because we will be building something that we already have built in a previous training, the essential training. So I'll add quite a few nodes and I'll be quite up-tempo. I'm not going to go deep into the logics of those nodes that I'm adding because all of that is already covered in a previous training. Our goal is to get a setting to a point where we can add cloners to the available design, to the design that we will build. So with that said, let's just get started. Obviously, we will need a particle root because that is a necessity for any particle system. We always have to have a particle root. We always have to have a type of emitter. So in this case, I'm going to go for primitive emitter. And we need some kind of a renderer. I think for the very start, just so we see things working, I'm going to add a point renderer. So I'm lifting the primitive emitter a little bit higher up here in the scene. And I'm adding a point renderer. Now we do need some kind of a motion in the scene. So I think I'm going to go for curl noise fluid effector. I'm going to add that and I'm going to make some alterations to this node. So I think I'm going to set a very small fluid simulation speed and I'm going to increase significantly the noise amount. And I think the noise scale could be smaller too. So 0.15 here. So simulation speed 0.03, curl noise amount 300 and noise size is 0.15. Yeah, I see this is definitely curling. This is definitely working. That's great. I'm going to hit 0 and come back to the active rendering camera. So we had point renderer just as a preview tool. What we actually want to use here is a trail renderer because we want to have everything in actual geometry. So instead of having sprites, we're going to go for trails and we're going to express these trails in extruded geometry. There we are. Everything is definitely working, but it requires a couple of alterations before we add clones here. So first thing, I don't think I need that great many particles. In the primitive emitter, I'm going to reduce the number of max particle count. Instead of 30,000, we could easily suffice with 8. I'm going to match this number in the particle root because that's where we set an allowance. So if we are using 8,000, we should be asking 8,000 from the GPU as well. So with these numbers set to 8,000, I see that the simulation is rather smooth. Everything is fine. Trail renderer could be thicker though. So in a trail renderer node, I'm going to increase the thickness to perhaps something like a 3. Now it is rather fast though. So I think I can set the time stretch in between the root and particle root and slow things down a little bit. There we go. So there's our time stretch and I'm going to relink the particle root via time stretch. And if I set it to something like 0.2, I see that it's definitely slower. Well, in fact, we can allow ourselves a little bit more speed. So maybe 0.4. So this is the initial setup that I rushed to set up. Now we can start talking about new nodes and new techniques that we haven't spoken of yet. So what if we want to have points on the ends of these trails? There's two ways we can do that. We have a mesh renderer in particles That is a great node. So if we just connect it to the particle root and, for instance, output a shape 3D from it, we will have little meshes on the ends of these trails. So all of a sudden, every single particle is expressed as a sphere, as a 3D object. And that is great. This is a very valid, very nice technique. But what if I want to have these shapes in various sizes and perhaps various colors? That would require adding quite a few of mesh renderers, all with the different colors, all with the different sizes. So this is not necessarily a very sufficient workflow. So there is a better way to render your particle sprites to a 3D object. And that is, instead of using mesh renderer, converting your particles to clones. So let's do that. I'm going to add a clone to particles node. I'm going to connect it to the root of the scene. And as you see, there's a couple of inputs here available in the bottom of clone to particle. So the first one is the particle node. And as I'm hovering over this input, I see that the available hookup points lights up. So I can choose either hookup particle root, so the whole system would be accounted for, or a specific emitter, should you have several emitters, and if those emitters has specific effectors, so on and so forth. But so in this case, I think I'm quite happy to connect a particle root here. Just like any other cloner, this one requires some kind of output. So I'm going to go for shape 3D and connect it to the clone to particles. I see it's working. It's just a few clones here though. That is because in clone to particles, our number of clones is set to 5. So it's a very small default setting. Since I have 8,000 available, I think I'm just gonna go ahead and use all 8,000 here on the number of clones property. So at this moment, we have a setting that is rather close to what we had with a mesh emitter. I'm just gonna make these particles smaller. So in the clone to particles, there's a size property. Clone scale, I'm just gonna make it smaller. So where is that big advantage of using clone to particles instead of a mesh renderer? Well, now I can easily set size randomness straight in the node. So all of a sudden, all of these particles are in a different scale, and that's great. And I have a vast pool of available effectors to choose from to further alter the look and the design of the setting. So if I go now for the effectors and choose something like turbulence, for instance, and perhaps take on the uniform scale property and make them bigger. All of a sudden, our particles are oscillating in scale all across the simulation. Maybe it should be a little bit slower. So 0.3 here, and let's flush the scale X to 2. There we go. All of a sudden, two systems are working hand in hand, producing a much more intricate, much more interesting design. That is actually true throughout all notch use. There is a lot of tools that make great things on their own, but they actually talk together via connections and they can benefit from each other's strengths. So in this particle chapter, we'll have quite a few workshops that will allow us to see those beneficial connections. We're gonna work with cloners as we are now. We're gonna work with deformers, and you're gonna see how one and the other connects and enriches your design. So with that said, I think there's one more effector that is needed, and that's color ramp effector. As I mentioned, it would be nice to have these spheres colored in different colors. So I'm just gonna go ahead and add color ramp effector. I'm gonna connect it to the second input, clone to particles effectors. And now I need some kind of a ramp that would define the colors that I'm gonna use. So I'm gonna grab a color ramp. I'm gonna connect it to the first input here. And I'm gonna increase the number of control points or operators. So in this case, I want 3. Just gonna set a gradient from yellow to, let's say, light blue. There we go. I don't necessarily like the distribution of the color. So instead of the position X, I'm gonna go for random value. And there we are. Now we have clones. They're colored in various colors and they are oscillating in scale, and we can definitely add more and more effectors to make this more intricate, more interesting. I think one more thing that I definitely would like to do here is to affect the color of the trails. And I can do that by connecting the very same color ramp to the first input here in a primitive emitter, which states color control node. So let's just do that. I'm going to connect it there, and let's see what results we are getting. All of a sudden, I see that my trails are red. And towards their death, they're changing color from red to yellow to blue. That's great. I can further control how these colors are distributed via color control property here. So instead of input color, I'm going to go for random color, as we did set a random color here in the color ramp effector. So at this point, I have to ask myself, is this setting pretty? It absolutely is not, but I think it proves the point. I don't think I chose the very good colors here for this design, but I'm sure that you're gonna make some better choices for colors, better choices for post-processing, so perhaps you're gonna add some post effects. And once you're done further exploring this setting, the clone to particles, meet me in the next workshop where we're gonna talk about particle physics and collisions. Welcome back to Notch Intermediate course, Particle chapter. In this upcoming workshop, we will be covering particle physics. So here we have a finished setup, and this is the design that we are more or less after in our upcoming work. So we're gonna go for the third layer, particle physics start. And let's just talk about the available nodes here in the scene. So first of all, we have a floor. Floor is set up with a grid generator. We have a camera. We're actually looking through the camera now. We have several lighting nodes, the very same ones as we've used in a previous workshop. And here on the top, we have a couple of new nodes. So let's talk about all of them. First of all, we have a sphere. The sphere is a center element. We're going to use this sphere as a mesh emitter. We're going to spawn our particles from it. So for a better communication, I would suggest that we rename these nodes to more appropriate names. So I think I'm going to start by naming the shape 3D into a sphere emitter. And then we have a ring. So this ring we could use for the collisions, for instance. I think I'm just gonna call this a ring then. And then further down we have a null. So this null is a pivot point for our shape 3D for this capsule. So it would just go round and round with the help of the continuous modifier. So I'm gonna name this capsule. This as well will be our collision object. Now, a good reason to name nodes, by the way, is the fact that you can find them much easier in your node graph if your node graph becomes quite fast and big. For instance, if I have several 3D objects, in this case there's this sphere emitter, the ring and capsule, and I need to find specifically capsule, and I'm somewhere in the corner, or there's a ton of these shape 3Ds and they're not named, I would be lost. But since I have given a specific name to that node and I want to find it, I can just press Ctrl F and type in capsule. And as soon as I type it in and hit enter, that node will be brought to the center of my node graph. So this is just a very good way to keep your node graph a little bit more accessible, a little bit more readable. So with that said, I think we're ready to start. I think I'm going to make my viewport smaller, so we have more space for the nodes. Let's begin. Let's start by adding a root. We definitely need a particle root. And as mentioned, we're going to use this sphere as an emitter. So we need a mesh emitter. So I'm going to grab mesh emitter. It comes in hashed out red, indicating that it requires some extra information. That extra information is the very mesh that it should be working with. So I'm going to grab a sphere emitter shape 3D and I'm going to pipe it into the first object of the mesh emitter. There we go. So now it's not hashed out red anymore. Now we have a correct and ready setup. We need some kind of a renderer. I think we can start with the point renderer. We're going to use this as a proxy. We're going to delete this node later on, but this is a very good node just to make sure that things are working. And if I zoom in a little bit closer, I see that indeed it is working. We are spawning particles by this mesh emitter, and all of those particles are now hanging on the vertices. We don't have any motion at all, so I think this is a good time to add some kind of a effector. In this case, since we're going to be talking about particle physics, I think we can start with the node that is responsible for the physics in particle system in Notch. So we're going to go for SPH. So the SPH acronym here stands for Smooth Particle Hydrodynamics. As soon as we add this node to the particle root, you will notice that all of a sudden the particle starts to go down. It's a little bit hard to read probably, so I'm just going to zoom in. So all of a sudden, these points have gravity. And that's great. But before we make any alterations towards a SPH node, or before we add any collisions, I think we should reduce the particle count. In this case, I don't think we will need that great many particles for the simulation. And I think it will be much easier to read the setting if the actual particles are expressed as cloners, so that they would be in a geometry, just like these shapes right here. It's just going to be easier to read, and it's going to look much better. Let's make these alterations. So in the mesh emitter, I'm going to drop the max particle count to 8,000. I'm going to set the same number in the particle root. There we go. And now I'm going to add a clone to particles node. I'm going to feed this particle system to the first input of the clone to particles. And I'm going to give this cloner a shape 3D to clone. There we go. Now we're set up. I see that the particles are falling down. That's great. Obviously, there are some changes that are still needed. For instance, we have just a few particles expressed as cloners. So in the clone to particles, we might as well bump these numbers. Instead of 5, we could set it to, let's say, 1500. How would that look? Yes, a little bit better, although they are quite too big. So in a clone scale, I think I'm going to reduce the scale quite a lot. Yeah, I think this looks better. Can we afford more? Can we go for something like 3000? Yes, I think 3000 is a good number. So if in our final output we're using 3000, we might as well bump down the numbers in the mesh emitter and in the particle root as well. So I'm going to just even out all the numbers. So it's 3000 in the mesh emitter. The closest number available for us here in a particle root is 4000. So I'm going to set that. And yes, we have 3000 here. There we go. This looks more coherent now. That looks just way better. I am not necessarily happy with the length of particle life. I think they could live a little bit longer. So we can alter that in the mesh emitter. Under the emission life property, I'm going to set 15. So particles lives 15 seconds. That's significantly longer than what it was set by default. Well, great. Now we have this setup. It's all ready. I think we can add a collision, or we can set up collision with a floor, and then we can talk more about SPH properties. It's going to be much more clear on how this node works when we actually have some kind of a collision happening. So I'm going to grab a collision effector. And we need a collision effector so we could tell particle system what 3D object should it be colliding with. In this case, we want to collide with the floor. So I'm going to go ahead and find the floor node. So this is my floor. And I'm going to connect the shape 3D of the floor to the first input object node in the collision effector. So with that done, now I see that my SPH-based particles, which are dropping down, are colliding with the floor that I had in the scene. Great! So let's talk a little bit about SPH effector now. SPH effector is responsible for all the physical properties available for us in this scene. So we can set the weight, we can set the viscosity, gravity, and so on and so forth. Quite a few settings. And I'm not going to go through all of them at this given moment, but depending on the simulation that you're building, you might want to alter one or the other to your liking. I'm just going to remind you that there is a link to a manual page about this node. So if you want to read up more elaborately, you can always do that by just hitting the question mark here. Although there is one setting that I definitely want to change here, I want a bit more dampening. I don't want them to jump so high up. I want them to jump quite less. Let's see. Yeah, I think 0.5 on a dampening property is actually way better for us here in this simulation. I like that quite a lot more. So let's talk about collision now a little bit. If I zoom in now to the very, very bottom of the simulation, you will see that some of the particles are actually hitting the floor and they're sinking into the floor. And that is because this particle system still thinks about the points. Points are hitting the floor. So regardless the fact that our shape 3D is a little bit bigger, this simulation is still going for that very point, for that very little sprite that is inside of the shape 3D. So how do we adjust, or how do we compensate? In the collision effector, we have a property called point collision radius. If we increase the point collision radius, all of a sudden we lift up the floor, or we give a little bit more space. So let me just do that again with the clone to particles enabled. So this is the default setting, and we are sinking into the floor. And what we want is a little bit bigger offset, so we hit the very, very tip of the floor. There we go. I think this is much, much better. In fact, we don't really need the point renderer anymore, so I'm just going to disable that. So I'm hitting Control 1 to kill it off, to stop it rendering on the screen. So this is definitely getting somewhere. I think I'm rather happy with the collision effector settings, and I'm quite happy with the SPH effector. What I would like to have is more collision. So I want this capsule to collide with the particles, and I want this ring to collide with the particles too. So I'm going to grab the collision effector, put it a little bit to the side, and I'm going to connect the very same capsule to the same input of object node. And I'm going to do the same thing with the ring. And let's see how does that work now. So let's just restart the playhead. There we are. We are colliding with a ring, and we are colliding with a capsule. I think one thing that looks a little bit odd here is the fact that there are particles spawning here at the top of this emitter. It just does not look right. I think we should fix that. And we can do that with an effector. A specific effector that I have in mind is a kill box effector. We just don't want those particles to spawn here in the top. We just don't want to have anything there. So I'm going to connect it to the root, and I'm going to lift it up a little bit higher so it covers the top of the sphere. I think now it makes more sense. And in fact, I think we could have some randomness towards the size of the particles. So in the clone to particles, I'm going to increase the size randomness a little bit, so it looks the tiniest bit more dynamic. There we go. Perhaps one more effector would be nice here, something like vortex, so the particles slowly twirls as they are going down. There we go. I see that the direction is not necessarily towards where I want it to be, so I'm going to change the rotation pitch to 90 degrees. I'm going to lift it up a bit, and I'm going to reduce the radius. There we go. Perhaps it could be a bit higher up, and it's quite strong, so the amount could be quite smaller, maybe 0.2. Yeah, so let's flush this number too. Should we have it a bit lower? Yes, I think 1.3 is a good number on the position Y. And we're gonna keep the radius at 2.1, and we're gonna leave the velocity amount at 0.2. Again, a little reminder, all the altered parameters in the node is always marked up a little bit brighter. So as you see, I've changed the position Y, rotation pitch, velocity amount, and radius. I think we are ready to add one more collision object here. In this case, I don't want this to be a primitive. I actually want to use a node that we haven't really used much yet. I want to go for the text node. It comes under geometry bracket. Just gonna pull it in, connect it to the root. And for the text node to work, there's two things required. First of all, we need to have some kind of a typography. So in this case, we need a font. I see that I have one already preloaded for me here in the resources, and that's geometos.ttf. There's a ton of online services that offers you typography in a TTF format. And a TTF stands for True Type Font. So with a typography available in the resources, we can choose that from the font dropdown right here in the node. So I'm going to choose Geometos, and we obviously need a text string. So I'm going to type in something like hello. And there we go. We are rendering a 3D text on screen now. There's a couple of things that I want to alter here. I would like this text to be aligned not from the left, but from the center. So I'll set the justification to center. And I think this could be bigger. So I'm just going to go ahead, press on a unified scalar. and I'm gonna make it bigger. In fact, I want this 3D text to be a little bit thicker, so it will have more depth. So I'm gonna use the extrude amount to address that. So I'm gonna make it a bit longer. There we go. And I'm gonna push it a little bit more to the front. Right, I'm gonna hit 0 again. Now I'm gonna grab this same text node and I'm gonna connect it to the first input of the collision effector object node. There we go. Let's check this out. It is definitely working. Although I think this text could be a little bit more interesting. If I was to hover over the inputs here in the bottom, I will see that the first one states effectors. So effectors is very, very versatile tool. Not only it works with cloners, it definitely works with deformers, and it does work with text as well. I'm gonna grab a turbulence effector and I'm gonna pipe it into that first input. I think I don't need any animation here at all, so I'm gonna set it to 0. I want this text to be static, but I want this to be a little bit more misshapen, so I just want this to be a little bit more fun. So perhaps some changes to the position Z, heading, pitch, and banking. There we go. So obviously all the effectors works here, so you can set it in any type of way you like. And there we go, this looks a little bit more interesting now. Of course, we could bring back the animations, but I don't think it really adds much value to the setting, so I might as well just keep it static. So here we are. These are the basics of particle physics in Notch. I think I'm gonna just delete the point renderer and I'm gonna walk you through the nodes that we have here in the scene as a reminder. So we have a mesh emitter, this sphere right here. It's emitting particles that are expressed as clones. So we have that setup right here. And then we have several effectors. We have a killbox effector that just stops particles from rendering from the top of this shape 3D. We have a vortex effector that spins the particles here in the bottom, and we have 2 effectors that are major contributors to this setting. So we have SPH effector for all the physics properties for this simulation, and we have a collision effector, and a collision effector is responsible for all the 3D objects that are colliding with these particles. So before we move on to our next setting, I think I'm going to show you something that might make the setting a little bit more interesting and interactive for you whilst you're working on your own design. We've spoken in an essential training about exposing parameters for Web GUI use. Not only you can expose variables based on the sliders, you can actually expose text as well. So if I'm going to go now for the text string property, press on a question mark and expose this property, I'm going to hit OK. I'm going to run to the project settings and make sure that Web GUI is enabled. Yes, now it is. And it's on a port 8910. If I now go to any browser that I have available for me and type in localhost with the same port number 8910, all of a sudden I have a text string editor. So I'm just going to start the playback, go back to my browser. So once I'm in my Web GUI here, I can change this text to anything I want. For instance, I'm going to mention a very crucial tool for this training to go smooth and good further. Coffee. I think we all should grab a nice cup of coffee and come back to further workshops where we're going to talk about particle and deformer relations. So see you there in a moment. Welcome back to Notch Intermediate course. By now we are definitely familiar with deformers and how we can alter and manipulate chunks. We did learn how to use particle physics in Notch as well. So let's combine the deformers and particle physics in one setting. So let's get started. I'm going to go for the layer 5 particle bone deformer start. And here we have an initial setup, so let me walk you through the available nodes. Here in the bottom we have shape 3D with a grid, so that's our floor. A little bit higher up we have a camera. We're looking through this camera now, and then on the side we have a small lighting setup. So we have fog scattering, skylight, and environment map. Then here on the right hand side we have an imported 3D object. We're already familiar with this object because we were using the very same 3D mesh in a deformers chapter. And here we have a sphere that we will use as a collider. So with that said, I think we're ready to start. So this 3D object we have here is already pre-shattered for us. I will make sure that we see the lines, so we see the little pieces that are contained in this 3D object. For us to be able to shatter this 3D object using particle systems, we need a deformer, and that deformer is particle bone deformer. So let's grab that. This deformer works just like any other. It has to be connected to the 3D object that we want to alter. And in a very particle bone deformer, we have to make one change. That is source mode chunks, as we do have chunks that we want to refer to. So with particle bone deformer added, we can take advantage of any and all effectors that are available in a particle system. For instance, if I grab something like turbulence and I just connect it from the particle bone deformer, you will see that all of a sudden this turbulence is taking place on the 3D model, and every single piece of this 3D model, every single chunk is treated as a particle. That's great. So let's build something a little bit more complex. Let's add some physics to this setting. As you may recall from the previous setting, we will need a SPH, smooth particle hydrodynamic node. So I'm going to connect that to the particle bone deformer. I'm going to hit home to reset the playhead. Yes, I see it's definitely working, but it's not colliding with any object just yet. So let's add a collision effector. So with the collision effector added, now we need to define what 3D objects should this system collide with. So I think we should start with the floor. There is my floor node. I'm going to rename it to floor. So I'm hitting F5. Let's call it floor. And I'm connecting it to the first input of collision effector. Let's test this. There we go. It's definitely working. It's not perfect just yet, but it's a good start. Let's connect this shape 3D as well. Let's connect this to the first input collision effector as well. There we go. Both of the objects are now being referred to in the system. We have a collision on both of them. I think I would like to have a little bit more of a dampening here in the SPH effector. So I'm going to increase the dampening property. Perhaps let's start with something like 0.4. Let's see how that looks. I think that's a little bit nicer because I don't necessarily like the fact that they scatter and then they bounce off so far and so big. Although I think we could easily go for a little bit bigger number. 0.5, let's see that. For this model to interact better with our simulation, I think in the collision effector we should change the mode from thin mesh to extruded mesh. Let's see if that helps us here. It absolutely does. All of a sudden the particles do not, or the chunks does not get stuck on the sphere. These chunks are referred to as a point, as a little particle. So setting up the correct collision radius or point collision radius is key. So as you see now, some of the pieces are going into the sphere, and that is because our point collision radius is rather small. So I'm going to increase that. Let's try again. Yes, this looks a lot better. Another thing that I think is missing in this setup is rotation. As our pieces are falling, they are absolutely static. They're not rotating, and we can alter that in a particle bone deformer. So let's make some alterations to this bracket right here. Deformer velocity amount, let's add a little bit more here. So let's set it to 5. Rotation velocity amount, maybe let's try something like -60. And rotation randomness, well, why not something like 0.5 on this property here? Let's see, it's definitely rotating now. Perhaps we overdid a little bit, so maybe the deformer velocity amount should be smaller. Let's try 2. And let's reduce the rotation velocity amount as well. There we go. I like this much, much better. Now, in fact, I don't necessarily want to see these lines anymore, so I'm going to come back to the 3D object. And I'm going to disable line rendering. So lines visible, I'm just going to take that out. So since we build this system that is using SPH and collision effector, We might as well build a little particle system here on the side and take advantage of both of those effectors. I'm going to start with the root node, and connecting it to the root of the scene with the shortcut Control R. We'll need a mesh emitter. In this case, we're going to use the very same mesh that we have here. There we go. And we will need some kind of a renderer. So in this case, I'm going to go for point renderer. Let's preview the simulation. So there we go. Particles are definitely spawning. They are following the chunks, but they have no animations. They have no effectors. So I think we're ready to connect SPH and collision effector to this little system right here. Now, before we do that, I think we can reduce the particle numbers. We definitely do not need 30,000 of them. I'm going to go for 8,000 particles on the mesh emitter, and I'm going to even this number out in a particle root. Now I can connect SPH effector and the collision effector to this new system that we created. Okay, I think we could push the setting a little bit further. How about changing some properties in a point renderer? I'm going to go for the texture circle.dds. I think I want my particles to be bigger, so I'm going to set the property of size to 3. And I want them to be random in size. So size randomness could be 0.9, for instance. Let's see. Yeah, that's already looking a little bit nicer. I kind of enjoy that. What if we add one more renderer? Geometry connection renderer, for instance. I'm going to connect that to the particle root. Let's preview that. Now I don't want these triangulations, so I'm going to tick off draw triangles, but I will enable lines. And I think I'm going to make sure that we are using a little bit less of them. So particle use amount, I'm going to set it to 0.1. It's kind of hard to read these particles when they're white, so I think we could give them a little bit of color with live color shading, for instance. So I'm going to just set a darker gradient. So they would get darker progressively as they're going through their life. There we go. Right, so I think we should make sure that the geometry connection renderer respects this live color shading as well. We can do that by ticking on use vertex colors. There we are. This is definitely getting somewhere. This is definitely looking better. One more property that I would like to change in a point renderer is the motion blur. We can always add some motion blur here. So I'm going to set it to 2. All right, I think you get the basics of this workflow. You can use particle bone deformer to take advantage of all the chunks that are available in your 3D model. If you're interested in how this model is built, you can always go to your assets, 3D meshes, and you will find it there for inspection. So the main or the key thing to remember here is that this system regards all the chunks as points, as a small little particle. Thus, we have to set a proper point collision radius, and we have to make sure that we have some kind of a velocity if we want those chunks to spin and turn. If we set none of the rotation velocities, it looks a little bit static. So I would always encourage you to set some kind of a deformer velocity, rotation and rotation randomness. That just makes things a little bit more dynamic. And of course, just like any particle simulation, this simulation works much better when you lock the frame rate of the scene. So in this case, I'm pressing on P and I see that my scene is locked to 25 by 25. If you don't want to lock the whole scene, you can always lock the frame rate inside of the particle bone deformer. There we go. I think we're quite there. I will leave you to explore this setting a little bit further, and I'm going to prepare for the next one, where we'll be looking at another deformer, a particle mesh deformer. So see you there in a moment. Welcome back to Notch Intermediate course, particle chapter. In this workshop, we will be looking at a particle mesh deformer. So particle mesh deformer is a perfect tool if you want to simulate something like a cloth. So I think we might as well just build that. So here is a finished setup and we have these starting points. So I think we can easily just go ahead, open the layer 7 and talk about the nodes available for us here. So we have a couple of nodes working with lighting. So that's a light and a fog scattering. We have a camera that we're looking through now. And we have this shape 3D, which is set to a plane. It has a material, and this material is built with a Truchet generator. And here we have a shape 3D set to a plane, and we're going to use it for mesh deformer. So let's get started. Let's grab the very needed node. So let's go for mesh deformer. So just like particle bone deformer, particle mesh deformer will work with all and any effectors that we feed through it. So I think I'm going to start with something like turbulence. There we go. Let's restart the playhead. Yes, it's definitely working. It's a little bit rough, but we can definitely fix that. So I'm going to reduce the velocity amount for the start, maybe 0.5 on this property right here. This already looks a little bit better. We are building a cloth simulation, so obviously we would make do with a cloth effector. So I'm going to add that as well. In fact, I'm going to make sure that that's the first effector that is being considered by Notch. So again, the stacking order here is quite important. So first we're going to apply cloth, then we're going to apply the turbulence. Let's preview. Yeah, this already looks a little bit better. I'd say it would be nice if it wouldn't turbulate or go that far off the screen. So maybe something like spring effector would work for us here. So we would just bring it back and forward. Let's try that. Yes, indeed it works, but it's a little bit too tight, the spring effector. So I'm going to reduce the spring strength. Let's set it to 0.3, for instance. Restart the playhead. Yep, this works, and this looks much better. Now, one thing that I would like to do here is to make sure that these corners are always static. I don't necessarily want this simulation to fly off to the left, right, or the bottom. And I can actually do that by using a weight map deformer. We are already familiar with that, so we're going to set that up with a gradient picture, and we're going to make sure that these corners are pinned and are always static. So let's just make that happen. So I'm going for generate weight map deformer. I'm going to connect it to the same shape 3D. Again, stacking order is important. First, we want to generate the weight map. Then we want this generated weight map to be considered by particle mesh deformer. And then we will have a correct simulation as we anticipate. So let's grab a gradient. So we have this reference picture for the weight map to work with. So I'm going to feed it into the first input image. Let's preview the gradient. It is linear by default. I think I want this to be radial. And I think I want to have a bigger inner range. So I'm going to set it to 0.9. So all of a sudden we have a centerpiece that will be disregarded, and we will have corners that will be pinned. And let's just preview that. Let's make sure that mode is set to texture, because without setting the mode to texture, generate weight map wouldn't know that it has to look to this gradient. Now it does, and we can preview how it looks. So show weight map. Okay, so now we have one area that is active and one area that is inactive. Let's preview. So as you see, I started simulation and it's still not working as expected. And that is because these two deformers are not talking. If now I grab the output of the generate weight map deformer, you will see that two plausible hookup points lights up. So that's generated weight map and mapping. I think we want to pipe in the generate weight map to the first input, generated weight map. I'm going to restart the playhead. And there we go. As we've spoken, we have two areas of influence. The center is where the simulation is taking place, and the corners is where it's pinned down. It's doing what I requested. It's definitely working, but it's not looking smooth. It's not looking slick. So if we think back to the deformers chapter, you might remember that we used something to address that. So we do have smoothing deformer. So I'm going to add that as a last point in the chain. So we are generating weight map, which pins the corners. We're applying that on a particle mesh deformer, which is deforming this shape 3D with cloth, turbulence, and spring effector. And then we're going to smooth everything out with a smoothing deformer. I'm going to set smoothing iterations to something like 8. Let's preview. Yeah, that definitely looks way better. In fact, we can push this a little bit further by making sure that the particle mesh deformer is set to a locked frame rate. We definitely have all our scene locked to a specific frame rate, But if you don't want to lock the scene, you can always lock just a very deformer. So fixed update rate, yes. Fixed update rate frame rate, let's set it to 25. Let's preview. All right, in this case, not great many things changed because again, we had our whole scene locked up, but this is just a good thing to remember and to know. So now we're interacting with effectors that already have their own animations. But let's add one more effector to the scene and let's interact with this setting. I'm gonna go for primitive collision effector. Now we already are familiar with a collision effector. So primitive collision effector does not take account of external 3D object. It actually has pre-built primitive types inside of it. In this case, I think I want to go for a sphere. I want the sphere to be quite smaller. So the big advantage of using primitive collision effectors, it costs way less for your GPU to calculate. And if you're going for something like plane, box, or a sphere, that is just a more viable option. So I'm gonna bring it up a little bit and restart the playhead. So if I bring it down, as you see, all of a sudden is interacting with this cloth. So we are dipping in the primitive collision to the cloth, and the cloth is behaving in accordance to how this sphere is hitting it. I'm gonna pull this a little bit higher up now. So before I leave you to further explorations, I'm just gonna mention a couple of properties of generate weight map deformer in this specific setting. We can always invert the generated weight map. Perhaps we want to have the corners dynamic instead of the center. And of course, we can use any generator to our liking. So for instance, I can always grab a star generator. I'm gonna swap this gradient with the star. There we go. Again, we can invert this setting. I think it actually looked much better when things around the star was moving about. There we go. One thing to note about generate weight map deformer while it's working with particle mesh deformer, it's not animatable. So it grabs the first frame available for it when the simulation starts. That's why we have an empty space when we hit home or when we hit a rewind button. And once that first frame is accounted for, that is exactly what is being used for the rest of the simulation. You're not restricted to just generators available in Notch. You can bring in any and all PNG or DDS file to use as an input for generated weight map deformer. So I think I'm going to tick off the show weight map and I'm going to leave you to further explorations. And once you're ready, I hope to see you in the next chapter where we will be talking about fields. See you there.